Okay, let's dive into this. Welcome to this explainer, where we're going to navigate a highly specific, totally crucial section of the FE exam reference handbook. We are focusing laser tight on pages 23 through 25. This covers everything from electrical safety all the way through toxicology, stopping just right before the carcinogen section. If you want to maximize your test score and completely avoid those common exam traps, well, you're in the exact right place. Here's our roadmap for today. We'll hit electrical safety, toxicology and dose response, the LD50 versus LC50 differences, chemical interactions, exposure limits, and then a high-yield summary. This maps directly to the checkpoints you need for the exam, so let's get right to it. Starting off with Section 1, Electrical Safety and Shock. So, the absolute most fundamental concept to understand here is that the severity of an electrical shock is entirely dictated by the amount of current passing through the human body. And notice, the FE Handbook expresses this electrical current in milliamps, or MA. There are three critical regions you absolutely must recognize for the exam. At 1 milliamp, you just feel a little tingling, right? At 5 milliamps, it's a slight shock, but you can still let go. But row 3, 6 to 16 milliamps, is crucial. This is the let go or freezing range where you actually lose muscular control. Moving down past the extreme pain threshold, we hit the second critical region at 100 milliamps. From 100 up to 2000 milliamps, ventricular fibrillation occurs. That's an uncoordinated pumping action of the heart where death becomes highly likely. Finally, above 2000 milliamps, you're looking at cardiac arrest, internal organ damage, and severe burns. Lock in those three specific zones, 6 to 16, 100, and over 2000. Now, what's really interesting about this slide is that this is our very first major exam trap. The FE Handbook uses milliamps, but exam questions absolutely love to trick you with values given in amps. You've got to strictly check your units. Just remember, 0.1 amperes equals 100 milliamps. If you forget to convert, you might calculate a current of 0.1 and think, oh, that's perfectly safe, completely missing that it is actually the deadly 100 milliamp ventricular fibrillation threshold. All right, moving on to Section 2, Toxicology and Dose Response. Let's shift gears from electrical physics over to chemical toxicology. So, toxicology is basically the study of the harmful effects of chemicals, and a dose-response curve relates the amount of a toxic substance received, that's your dose, to the percentage of a test population that actually shows a specific toxic effect. The general rule here is pretty simple. As the dose increases, the toxic response increases. But keep a close eye on the units. Dose is frequently expressed in milligrams of substance per kilogram of body weight per day. Section 3 is LD50 versus LC50. Consider this a giant "do not confuse" warning sign. Let's compare these two side by side because it's a frequent exam trap. LD50 means median lethal dose. Think D for dose. It's the single dose expected to kill 50% of a test population, and we commonly associate it with oral or skin exposure. The units are typically milligrams per kilogram of body weight. Now look at LC50. The C stands for concentration. This represents an airborne concentration expected to kill 50% of a test group during a very specific exposure period, like 1 or 4 hours. It's measured in air concentration units. So D is for dose on the skin or ingested, C is for concentration in the air. Oh, and by the way, if you happen to see LD10 or LC10, they work the exact same way, just for a 10% lethal response instead of 50. So, the crucial point is how you actually read the comparative LD50 values table in a handbook. You don't need to memorize the exact values, but you must know this rule. A lower LD50 means greater acute toxicity. It feels a little counterintuitive at first, right? But think about it. If it only takes 1 single milligram per kilogram to kill 50% of the test population, that chemical is way more toxic than one that requires a massive 1,000 milligram dose to do the same damage. Smaller number equals deadlier chemical. Section 4, Chemical Interaction Effects. Continuing on page 24, what happens when multiple chemicals combine? Well, the handbook identifies 3 key types of interactions, and it helps to visualize these using basic math. First up, additive. This is exactly what it sounds like. The combined effect just equals the sum. 2 plus 3 equals 5. Easy. Second, we have synergistic. This is where the combined effect is much greater than the expected sum. Think, 2 plus 3 equals 20. A classic FE exam example of a synergistic effect is cigarette smoking combined with asbestos exposure. The damage is exponentially worse than either one of those alone. Finally, antagonistic.
This happens when the combined effect is actually smaller than the expected additive sum. So normally, 6 plus 6 equals 12, but here it might only equal 8. They counteract each other. When you're sitting there under exam pressure, just picture these simple math equations in your head to quickly recall the definitions.
Section 5, Workplace Airborne Exposure Limits. This is the final technical topic on page 25. And this brings us to our second major common trap. In the handbook, you'll find a table of allowable workplace exposure levels for selected compounds. Now, don't memorize these. You just look them up during the test. But whatever you do, do not confuse these airborne limits with the LD50 values we talked about earlier. Airborne exposure limits are expressed as milligrams per cubic meter. That's a volume of air. LD50 values are expressed as milligrams per kilogram. That's body weight. It is incredibly easy to pull a number from the wrong table if you're rushing and not paying strict attention to your units. All right, our final section, the FE exam high yield summary. We've covered a lot of dense material, so let's lock in your core actionable takeaways for pages 23 through 25. Remember your electrical thresholds. 6 to 16 milliamps is your let-go range, and around 100 milliamps is your ventricular fibrillation danger zone. For toxicity, remember that inverse relationship. A lower LD50 means greater acute toxicity. For chemicals, synergistic means the interaction is much greater than the expected sum. And finally, you have to use your digital handbook efficiently. The exact search keywords you want to type in on test day are electrical safety, dose response, LD50, chemical interaction, and exposure limits. So, as we wrap up this explainer, I want to leave you with this thought. How are you going to manage your time using that digital handbook index on test day? Knowing the concepts is really only half the battle. Knowing exactly where to find the tables and definitions rapidly is the other half. Congratulations on mastering pages 23 through 25, right up to the carcinogen section. Keep practicing those keyword searches, always check your units, and best of luck with your preparation.